In this video, I'm going to go through the solutions to the mini test on transformations. The first question is that g of x is 1 over x minus 2 plus 1. We are supposed to find first the base function. Since this is a rational function, the base function is 1 over x. Now we are supposed to write the mapping notation. If you look at this one, and the general form of transformation of function, you can see that a is equal to 1 because there is nothing multiplied here, it's just 1. B is equal to the coefficient of x, which is 1, which is here. You don't see it, so it's 1. Then we have to find h. Since the formula is h x minus h, so h is 2, and k is the constant here, which is equal to 1. So the mapping notation becomes x and y goes to x over b, which is x over 1, which is x, plus h is 2, and y is going to be transformed ay, which is 1 times y, which is 1, y, plus k, which is 1. The next part of the question asks us to complete the table of values using the above mapping notation. Now, in your test, I've already set these values to -2, -1, 1, and 2. Now, if you look at the base function, when x is -2, then g of x is 1 over -2, which is -0.5. If x is -1, is 1 over -1, which is -1. If x is 1, then is 1 over 1, which is 1. If x is 2, 1 over 2 is 0.5. Now to find g of x, which is the transform function, the table of values, we have to use the table of values for the base function and the mapping notation to find the new values. So let's start with x. When x is -2, we put it back in this equation. X plus 2 is -2 plus 2 is 0. When x is -1, we put it back again in this equation. So -1 plus 2 gives you 1. If x is 1, 1 plus 2 is 3. If x is 2, 2 plus 2 is 4. Now we use the y values. When y is -0.5, then -0.5 plus 1 is 0.5. When y is -1, -1 plus 1 is 0. When y is 1, 1 plus 1 is 2. When y is 0.5, 0.5 plus 1 is 1.5. Now the next part says graph the base function and transform function using above TOVs. Now when you are plotting the rational functions like this one, remember that I said that you have to find the vertical asymptote, horizontal asymptote, x-intercepts, and y-intercepts. And then using these and a couple of other points, plot the graph. So we are going to go back to our transform function and try to find the vertical asymptote. The vertical asymptotes are the zeros of the denominator. Now if the denominator is x minus 2, we are going to solve x minus 2 equal to 0, so we find x is equal to 2. This means the vertical asymptote is x equal to 2. So we get a line like this one. For horizontal asymptote, we said that we are going to find the maximum exponent of variable in the numerator divided by the maximum exponent of the variable in the denominator. If we end up with the variable in the denominator, then it means that we have to let x go to infinity and find the value. Otherwise, we just simplify the rational function. So, to find the horizontal asymptote here, what we are going to do is that we are going to find the common denominator. The common denominator here is going to be x minus 2, so I'm going to write it down here. So I'm going to say g of x is the same as 1 over x minus 2 plus, I multiply 1 by x minus 2 divided by x minus 2. So I get x minus 2 over x minus 2, which is 1. Now if you add these, since the denominators are the same, I add the numerator, so I get 1 plus x minus 2 over x minus 2. Now x stays x, so 1 minus 2 becomes minus 1, so x minus 2. Now the maximum exponent of x in the numerator is x, the maximum exponent of the denominator is x, x divided by x gives you 1. So this means that the horizontal asymptote is going to be 1, y equal to 1. Y equal to 1 is going to be this line. Now our graph, as we know from the base graph, which is going to be 2 branches, is going to have 2 branches, but we have to find out where exactly are the branches located. To do that one, we are going to find the X and Y intercept. The y-intercept is very simple. What we are going to do is that we are going to set x equal to 0 in g of x. If we set x equal to 0, we get 1 over negative 2, which is negative 0.5, plus 1 is going to give us 0.5, so it's going to be a point around here. Now, for x-intercept, we are going to set y equal to 0. So we have, when we set the common denominator, we had that g of x is x minus 1 over x minus 2. If g of x, which is y, equal to 0, so we get x minus 1 equal to 0, we crisscross or cross multiply, and then x minus 1 is 0, so x is 1. So we get this point here. So we have approximately a part of the branch which is going to look like this one, and the other branch is going to be reflection about the intersection of the asymptotes. So the other branch is going to end up something like this one. And if you want to plot the base function, which is y over x, we can easily see that x equal to 0 is 1 asymptote, x equal to 0, which is the vertical one, and for horizontal one, since the highest exponent in x in the numerator is 1, not 1, but the exponent is 0, but the coefficient is 1, and the highest exponent of x in the denominator, the term is x, 1 over x, then we let x go to infinity, 1 over infinity becomes 0, so the horizontal becomes the line y equal to 0. So the base function, as we did so many times in the class, becomes a graph like this one. Now we are going to do the last part of the question, is to find the domain and range of the transform function. From the transform function, you can see that the domain D is equal to x in R, and x can be any value except the vertical asymptote, and the vertical asymptote is x equal to 2, so x cannot be 2. And the range is going to be y in R, and y can be anything except the horizontal asymptote, and the horizontal asymptote as we found was y equal to 1, so y cannot be equal to 1. The next question is that you have the base function, which is f of x square root of x, and it has gone through a series of transformation. We are supposed to find the equation of the transform function. The first transformation is reflection in the x-axis. Since the priority of reflection is the highest one, so we can apply this reflection first. So we are going to say g of x is going to be minus square root of, and then x here. I'm going to write it as much space possible because as we go along we are going to add coefficient to every term here. Now the next transformation is stretched by a factor of 3 vertically, so I'm going to add a 3 here. Now there is a horizontal compression of a factor of 1 over 2. Remember, for horizontal compression or stretch, we are always using 1 over b. Since this one is 1 over 2, so this becomes 2 here. Then a vertical translation of 3 units down. So this means this becomes negative 3 here. And finally, a horizontal translation of 6 units right. So this one is going to be minus 6. So this is going to be our final equation of the transformed function. The next question is about graphing the function g of x, which has undergone a series of transformation. First of all, based on g of x, the base function is simply square root of x. Then writing the mapping notation. Now to do that one, first we are going to change the form of g of x so we can extract the information easily here. So I can write g of x as negative 2 square root of, since in the general formula the coefficient of x is 1, so I'm going to factor out 2, so I get x minus 1 plus 1. Now looking at this equation, I can easily see that my a value is equal to negative 2, my b value is 2, my h value is 1, and my k value is also 1. So my mapping notation becomes xy goes to 1 over b, which is 1 over 2x plus h plus 1, ay, which is negative 2y plus k. Now, given the table of value for the base, we are supposed to find the table of values for the transform function using the mapping notation. In your test, I've already set the values of x to be 0, 1, 4, 9. So using the base function square root of x, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Now using these values and the mapping notation, we are going to find the table of values for transform function. When x is 0, again I put these values back into this mapping notation to find x and y. When x is 0, 1 over 2 times 0 gives me 0, so x is 1. When x is 1, 1 over 2 plus 1, it gives you 1.5. When x is 4, 1 over 2 times 4 is 2 plus 1 is 3. When x is 9, 9 over 2 is 4.5 plus 1 is 5.5. For y values, I'm going to use these values and I put it here in this formula. So when y is 0, I get negative 2 times 0 is 0 plus 1 is 1. 1.5 times negative 2 is negative 3. Negative 3 plus 1 is negative 2. When y is 2, negative 2 times 2 is negative 4 plus 1 is negative 3. And when y is 3, negative 2 times 3 is negative 6 plus 1 is negative 5. So these are the table of values. Now we have to graph these two functions using the table of values. Now I'm going to go ahead and plot the base function first. When x is 0, y is 0, so it's going to be this point. When x is 1, y is 1, which is going to be this point. When x is 4, y is 2, which is going to be this point. When x is 9, which is off the graph, y is 3, which is going to be somewhere around this point. So my base function is going to look like the dotted line which I have plotted here. Now I'm going to plot the transform function. When x is 1, y is 1, so it's going to be this point. When x is 1.5, y is negative 2, which is going to be this point. When x is 3, y is going to be negative 3, which is going to be this point. And when x is 5.5, y is going to be negative 5, which is going to be around this point. So my function is going to look like a graph like this one. Now, the next part of the question is asking us what is the domain and range for the transform function. The domain, as you can see, is going to be all the x values, but the x values, they have to be greater than or equal to 1, which is everything to the right here. And the range values are going to be all the y values in the real numbers, but they have to be less than or equal to 1. The last question in your mini test was if f of x is given in the following forms, we are supposed to find g of x after reflection in the x-axis. As I mentioned in the class, when you are asked about the reflection of a graph on the x or y axis, always draw a point and then you say this one. If I reflected about the x-axis, I'm going to get a point here. Now looking at the new point, you can see that if the original point is, let's say, x and y, the reflected point about the x-axis is going to have the same x value, but the y is going to become negative x. And if I reflect it about the y-axis, you can see that the y doesn't change, but x becomes negative x. So, reflected about x-axis, we are going to multiply the function by -1. But if it is about the about the y-axis, we are going to replace x with -x. Here we have a reflection in the x-axis, which is this scenario. So you have to multiply your function by -1. So for the first one, you get g of x is a negative square root of x minus 5. And for the second one, g of x is -1 over x plus 7.